Say you've got a long report sitting on the office desktop you need to take on the road. What do? You don't pack up that desktop. You simply copy the file onto a USB flash drive to transfer the document to a portable device like a laptop or a tablet. Or say you're an IT admin looking to access dashboards and review analytics in mobile devices like smartphones. What makes this possible? Flash technology. Flash memory has revolutionized the storage industry with its speed, reliability, and versatility. In the next few minutes, we'll delve into all things Flash, how it works, its advantages, and its disadvantages. But for a deeper dive, you can explore our complete collection on all things Flash by clicking the link above or the link in the description below. So, what is Flash? Flash memory is a non-volatile storage medium, meaning it retains data even when the power is turned off. It's become the go-to storage technology for a wide range of applications, from consumer devices like USB drives to enterprise data centers. Flash memory architecture consists of several key components. At the heart of flash memory is the NAND cell, which is the basic building block of flash. NAND cells are organized into pages, and multiple pages are grouped together to form a block. Data can be accessed from any address within a given block, but data that is written to flash must erase and rewrite the entire block containing new or changed data. This erase before write characteristic is very different than traditional RAM. To write new data, the entire block must be erased first. This process, also known as erase and program, affects the performance and lifespan of flash memory. It also slows the overall performance of flash memory compared to traditional RAM, causing stress on the flash circuitry that results in limited lifespans for flash devices. There are primarily two types of flash memory: NOR flash and NAND flash. Let's take a closer look at each. NOR flash memory is known for its random access capability, making it suitable for applications that require fast read and write speeds. NOR flash is commonly used in devices such as smartphones, tablets, and embedded systems. NOR flash also allows individual bytes or words to be modified, providing flexibility for things like firmware updates. NAND flash memory, on the other hand, offers higher storage density and lower cost per bit compared to NOR flash. NAND flash is typically used in larger storage applications such as solid-state drives or SSDs and USB drives. It excels in sequential read and write operations, making it ideal for high-performance storage. Then there are varieties of NAND flash: single-level cell or SLC, multi-level cell, and triple-level cell. SLC flash provides the highest performance and durability, but comes at a higher cost. Multi-level cell flash offers a balance between cost and performance. Triple-level cell flash provides the highest storage density, but with lower endurance. Flash storage devices and systems boast 5 main benefits: high performance, resiliency, scalability, disaster recovery support, and cost efficiency. Let's look at each. First, high performance. It takes time to access storage and move data between a workload and storage resources. Modern flash systems can tout up to 3 million input-output operations per second. This is far faster than traditional magnetic hard drives. Resiliency is another advantage of flash. Modern flash storage devices are more durable than HDDs, particularly in read operations, because there are no moving parts, and they use combinations of hardware and software to enable redundancy and facilitate transparent failover between devices in a storage array. Some flash storage systems denote up to 99.9999% availability. The third advantage is scalability. Enterprise workloads are increasingly storage hungry. Comprehensive flash storage systems can typically provide high levels of scalability to hundreds of terabytes or more. Disaster recovery, or DR support, is another clear benefit. Flash storage systems are increasingly intelligent, with support for enterprise storage features such as clustering, multi-site replication, accelerated backups and restorations, and support for unexpected device failures. Finally, there's cost efficiency. Although flash storage can be more expensive per byte than traditional HDDs, flash storage can usually pack more storage onto far less space for lower power and cooling costs. When factored in with greater workload performance, flash costs can often be about the same as a traditional hard drive. Despite compelling advantages, flash storage poses several potential disadvantages. First, flash storage remains several times more expensive than traditional HDD storage when measured on a per gigabyte basis. Second, flash components have slower writes. Because flash components are designed to operate in blocks, not bits like with traditional RAM, a write operation will first erase blocks before rewriting them with new data, as we touched on earlier. This takes more time and slows write operations. If you have some write-heavy workloads, flash might not be the way to go. Flash is always faster when reading, but not writing. Another concern with flash is its limited lifespan. Write operations cause wear and tear on the electronic components of flash storage devices. Modern flash devices have been adjusted with effective technologies to extend working life, but most transistors fabricated into flash chips and devices are limited to about 10,000 write cycles. So flash storage might not be a suitable storage alternative for write-heavy workloads like video or other media creation. There is something of a fix for these drawbacks, though: hybrid flash arrays. These combine HDD and SSD storage. A hybrid array helps contain the price while delivering the performance benefits of both technologies. Before making any storage investment, it's wise to consider a few business parameters like your company's use case for flash. That includes the workload or application that the storage is intended to support. Your data access needs. This includes IOPS and read-write demands on the storage. Your requirements for capacity, security, and data management. And your current storage resources. Once you know these four things, it will be easier to make cogent decisions about flash and what its role should be in your storage architecture. If you decide to buy flash storage, you'll need to make some other decisions. For instance, you'll need to determine your requirements for IOPS speed. It's also important to understand the storage needs of the application. How much data is the application going to create now and into the future? This is a key part of any capacity planning in IT. And you'll need to be clear on the preferred form factor too. That is, what is the size, configuration, or physical arrangement of the storage media that you need? Flash is clearly with us for the long haul, and its future seems to point to greater capacity. Some vendors are already planning to boost the number of 3D NAND flash layers and increase bit densities. Manufacturers are racing to increase storage density while decreasing the cost per bit. Expect to see increased use of quad-level cell or QLC drives in enterprise storage, at least for read-intensive workloads. This brings devices with higher density and lower cost per bit into the mainstream for enterprise flash devices. Another development likely coming is the broad adoption of penta-level cell flash, or PLC. This uses 5 bits per cell to store data as opposed to 1, 2, 3, or even 4 bits per cell. Although PLC technology currently suffers from lower write endurance and performance, manufacturers are improving fabrication techniques and employing special algorithms to help offset these limitations. We expect storage protocols to continue to advance, things like NVMe or Non-Volatile Memory Express. As these improve, flash will perform at an even higher level. The evolution of flash will also feed into other technologies such as storage class memory, or SCM. SCM represents a new storage tier in the enterprise. It exists between SSDs and dynamic random access memory, or DRAM, with the aim of supporting latency-sensitive applications. Flash memory has revolutionized the storage industry. It offers speed, reliability, and versatility. And whether it's solid-state drives, USB flash drives, or embedded flash memory, flash technology will continue to drive innovation across a wide range of applications.